Hello world, my name is Evan and I am a vegetable grower, currently reaching out to you from Sao Paulo, Brazil. This series of videos is on the subject of seed starting, and this video in particular is about charts and graphics. This content is made for gardeners, farmers, and horticulturalists. The contents of this video are listed here. These charts are the ones I use to ensure that I purchase enough seed, that I seed in a timely manner, and that my seeds grow rapidly and consistently. These graphics, or ones similar to these, should be used by you to make for a more proficient grower. I also name some of my favorite resources to find concise and scholarly information. This first chart fulfills two duties at once. It lets a grower determine how many days will pass in between seeding and germination, along with the temperature germination is possible. The most important figures for each crop are highlighted in yellow, and this is what a proficient grower is striving for, yet may not always be possible. This is important for container culture, such as using 1020 flats, along with direct seeding or sowing seeds into the ground. For instance, crops such as radish and turnips, both being root crops of the Brassicaceae family, can germinate in less than a week for a wide range of temperatures, while some species of crops, such as eggplant, require warmer soil or media temperatures. Knowing this type of information can be vital to a grower for many reasons. If you know your crop will germinate in 5 days, then you can plan for its future. Where will the crop move to next? Will it be up-potted into a larger container? Will it be transplanted into a row, field, or garden? Or did you direct seed, and you must determine when your first opportunity to weed or cultivate the soil will be? You can see that this chart is not very precise, as the temperatures jump 9 degrees Fahrenheit in between each column. This data is great for a gardener or small farmer, yet if your livelihood depends upon it, and especially if you grow just a few species of plants at a time, do your own research and find the best scholarly advice for the soil temperatures required to attain rapid germination for your crop types. In general, the fewest days to germinate is best, as this will enable the soonest date to harvest and will ensure that the fewest amount of seeds rot in the soil or media. This isn't to say that you cannot plant into a cooler soil. As you can see for spinach, you could plant at 32 degrees Fahrenheit very early in the spring. As the days lengthen and the soil warms up, the days to germinate will rapidly decrease. Spinach would take 63 days to germinate if held at a consistent 32 degrees Fahrenheit, while in reality, the soils are continually warming as the upcoming days increase in sunlight and approach summer. In this respect, you can attain a harvest quicker by sowing into cooler soils than waiting for them to warm. Of course, growing in cells in a 1020 flat at a controlled temperature and transplanting into a field will always be superior in terms of time alone, but requires a lot of extra labor, infrastructure, and expense. This is an image of the USDA hardiness zones. Much more detailed maps can be found on the internet, and you can type in your local zip code to find the most accurate results. If you are located in another country, you should be able to find this data under another name. This is a very helpful graphic because it illustrates your local climate, quickly showing the coldest temperature annually in your area. This is most beneficial to perennial plantings, yet searching your local hardiness zones will often show you when it's safe to direct seed and transplant crops, along with when the end of your season will occur. These are known as the first and last frost dates. These dates are very important to outdoor growers. The federal minimum germination rate, yes, this sounds incredibly boring, is an important figure for growers. This ensures that all seeds sold commercially in the United States will germinate at a certain percentage when placed into the correct environment. This helps to inform the grower how many additional seeds they will need to start or sow to meet their needs. Most reputable seed packets will provide the particular germination percentage of their tested batch, creating a more accurate measurement for your production. As you can see, 80% of collard seeds must germinate, meaning that 80 out of 100 seeds will be viable. If seeding a flat with a single seed per cell, you can assume that 80% may germinate or produce a plant. While these are federal minimums, in general, germination percentage will be much greater if you purchase from a reputable seed source. You can see that if you were to buy a packet of 100 carrot seeds, only 55 may be viable. This is why you must have an understanding for seed quality and germination rates before planting a garden for your family, and certainly before signing a contract to fulfill an order. You should not invest money in tilling, amendments, infrastructure, or water, and then purchase low-quality old seed. This chart is provided to help you make correct decisions when sowing a seed. I found this chart in the Knott's Handbook for Vegetable Growers, which is an incredible reference and free PDF you can find on the InterTubes. And here, I'm using a screenshot to show the interrelation between a seed's weight and its seeding depth. You can see that lettuce seeds are very light, in which 10,000 transplants can be started from a single ounce of seed. The seeding depth is strongly correlated to this information, and the lightweight seed is sown at a depth of only 1/8 of an inch. Squash, which are very large seeds, think of edible pumpkin seeds, require 3¼ pounds of seed to start 10,000 transplants, and can be safely planted at a depth of 1/2 of an inch. In general, you can place a seed twice its width in depth. Seeds contain endosperm, which is their initial energy source for life. This energy is limited. Once it runs out, the plant must be able to create its own energy from photosynthesis. If the seed is sown too deep, it will not reach the light. If the seed is large and sown too near the surface, it may dry out and perish. While it may be in your interest to direct sow some crops into the soil, others should be started in 10-20 trays or flats for transplant. In general, larger seeded crops should be sown into a 72 cell tray, while smaller seeded crops will be happy in a 128 or 200 cell tray. This information is more important for a smaller commercial grower because they must maximize space and potting media use. Some crops, such as tomatoes, may start in a 128 cell, then after germination, throwing off their cotyledons and true leaves, they may be up-potted into a larger container, such as a 32 cell tray, and may be transplanted into the soil after this, or may be up-potted once again into even larger containers. Using the smallest cells possible without stunting the seedling's growth by limiting its root area is important to produce the most amount of plants in the smallest amount of area, saving space, water, nutrients, light, labor, and other aspects of production. Vapor Pressure Deficit, or VPD, is a chart I wasn't going to include as it can seem a bit overwhelming. Yet this graphic can really help boost growth and cut down on disease. Plants respond not only to heat, but to humidity in the air. With increased heat and lower humidity, the plant struggles to uptake enough water through its roots, especially when the plant is young. Conversely, in lower temps and high humidity, the plant doesn't need to uptake as much water, which decreases nutrient uptake and growth. The colors of the chart correlate to the colored key to the left of the screen. In general, for early plant growth and seed starting, you want to stay in the blue zone, which has a range of acceptable temperatures and humidities for optimal growth. This information is best for a small to commercial grower. Due to the fact that equipment must be purchased to measure these figures and infrastructure expenditures would be required to alter the environment beyond simple adjustments such as moving the seedlings to different areas. In closing, to sum up the previous slides, before you can reap a harvest, you must have an idea of how to sow a seed, how many you should sow, and when. These are the charts and graphics that I consult annually and will help you succeed as a grower. This slide is to reiterate that every seed will not grow, and you must seed for more than you plan to harvest, and thin accordingly. The example provided shows that 133 tomato plants are required according to my personal row density to fill a 100-foot row. Yet, when accounting for losses, I should start around 178 seeds for insurance against non-viable seed, human errors, and transplant issues, etc. This is my first YouTube video, and I intend on creating content regularly for growers, landscapers, and people which wish to understand agriculture. Horticulture and crop science seem to be shrouded in mystery for most of us, and I am attempting to create small lessons based on scholarly findings, which will most likely be PowerPoint based and boring, along with entertaining videos on farms and in landscapes. Now, if by some mistake you found this video and you learned anything from it, please understand that it took effort on my behalf and that I am doing it not only to create more efficient growers, but to give confidence to new gardeners and to aspiring horticulturalists. I would greatly appreciate it if you would like this video, subscribe, or comment, which may help me reach the next generation of growers. Have a great day and grow some veg.